Hello, in this video we're going to use Cramer's method to solve a system of linear equations. What you see here in front of you at the top is a system of equations with two variables, x and y, some coefficients a and b, and numbers c1 and c2 respectively. Now, to find the variables x and y, we need to use the determinants, so hopefully by now you know what that is. If you haven't seen our videos on the determinant, you may find it on our channel. Go ahead, look through it, and you may come back to this video when you're ready. Now, what we have here at the bottom is something called the primary determinant of this system of equations. And it takes coefficient a and coefficient b. And that's the first step. We need to find whether the determinant equals to 0 or not. And in case the determinant does equal to 0, that means that it either has infinitely many answers or it is incompatible. So if that's the case, you have to use Gaussian elimination, which is also covered on our channel. And Cramer's method will not work. However, if it's anything other than 0, then we need to do the following. We have to find the determinant that has the coefficient for x replaced with the c1 and c2, which were the results in our original equation. So you see here c1, c2, and you put them instead of the coefficient a, and you calculate the determinant, and then you do the following, the same for the determinant of y. So you replace b with c1 and c2. Then when you have your determinant for x and determinant for y, you can find the actual variables by simply plugging them into this equation where you divide the determinant for x by the primary determinant and the determinant for y by the primary determinant, and that gives you your variables. So pretty straightforward, huh? Now let's look at a particular example. So we will try and find the x and y in this equation. Let me zoom it out a little bit so we have more space. Let's go ahead and get started by finding the primary determinant of this system of equations. And the primary determinant will equal to it's going to be a 2 by 2 determinant of the second order. Now, as you can see, I've used some slightly inconvenient numbers for this example, just so that we can use the skills we learned in the properties of the determinant video. Again, I encourage you to take a look at it if you haven't, so that you're a bit more familiar with what we are going to do right now. And let's start by kind of simplifying this determinant and making it look a little bit nicer. And what we'll do is we will take out 25 from the first row, and we're going to factor out 10 from the second row. Let's calculate that. So we have 25 times 10 times our remaining determinant. So and that gives us -1, 3, 2, and -3. That equals 250 times 3 minus 6. That equals to -3 times 250, or -750. what does that tell us? We now know that the determinant is not equal to 0, so there has to be one particular solution that we will find by first finding this primary determinant, and then what we will do now is we will find the determinant for x. Let's replace our coefficient a with 225 and 50, and our coefficient b stays the same, so it's 75 and 30, negative 30 actually. Now, this can also be simplified. We can also factor out 25 in the first case, and we can factor out 10 in the second case. So 250 times, that's going to be 9, and this is going to be 3, 5, and negative 3. All right, so that gives us, we can actually simplify even further by factoring out 3 from the second column. So it's going to be 750 times 9, 1, 5, and negative 1. And that equals to negative 9 minus 5 times 750. And that's negative 14 times 750. And if you calculate that, that should be equal to negative 10,500. All right, so next let's find our determinant for y. So same steps as with determinant of x. We first rewrite our coefficient a, nothing changes, and we plug in the coefficient or the number c instead of coefficient b. Again, let's simplify. 250, since we factor out 25 from the first row and we factor out 10 from the second row, multiplied by negative 1, 9, 2, and 5. All right, so no way to simplify this further. Then let's calculate. And we have 250 times negative 5 minus 18. Or that's 250 times negative 23. And that equals to negative 5,750. All right, now we have our determinants, and that means we have everything we need to calculate the variables x and y. So the original determinant, which is negative 750. We have the determinant for x, which is negative 10,500. And the determinant for y, which is negative 5,750. So let's find our x first. And x, according to the formula, is going to equal to negative 10,500 divided by negative 750. Now, let's simplify this. It's 1,050 divided by 75, and we can factor out 25, or actually cancel it out. So we have 25 here, and that's 3, and 1,050 divided by 25 is going to be 42, I believe. It's 42 over 3. Or that equals to 14. So our x equals 14. And let's find our y. And that is negative 5,750 divided by negative 750. So again, let's simplify this. We can cancel out 25 on both sides, and that's 3 here. And in this case, it should be 23. So that doesn't divide to give us a whole number, so we'll just leave it at that. It's 23 over 3. And just like that, we find our x and our y. See, in this example, it would have been faster if you just used substitution. Just take your x, express it as y, and then plug it into another equation. However, when you're faced with something bigger, like for example, a system with 3 variables, the more variables you have, the easier it gets to, the faster it becomes to solve it through matrices when compared to just substituting things. Now, and speaking of matrices and systems with 3 variables, I am going to give you a homework problem. In case you have troubles with it, we are going to make a separate video with the solution. Now that you watched this video, you're one step closer to achieving your academic goals. Well done! There's always more to learn, so check out our other videos and don't forget to subscribe.